Hi, and welcome to this short video on the topic of electric fields. Before continuing, please make sure that you've watched and understood the static electricity video first. An electric field is something that causes an electric charge to feel a force. There's an electric field around every single charge. It's for this reason that this positive charge and this negative charge will be attracted to one another, and that these two negative charges will be repelled by one another. Electric fields explain how this negatively charged balloon can stick to this wall. The electric field around the balloon is causing electrons in the wall to be forced away from or repelled by it. Because this bit of the wall is now positively charged overall, there will be a force of attraction between the balloon and the wall. Now this all sounds marvellous, I know, but I'm sure by now you're wanting to know a little bit more about how these fancy electric field thingies actually work, so here goes. The only type of electric field which you need to know about for your exam is that which is produced by a charged sphere. Have a look at this positive charge. We can draw electric field lines around it to show us what its electric field looks like. Starting off from the surface of the sphere, the field lines will point outwards from its centre, like this. When the object is positively charged, you should draw arrows pointing outwards onto each field line, like these. Now, if the object is negatively charged, these arrows should point inwards. But what does it all mean? Well, the arrows show the direction of the force which will be exerted on a small positive charge which is placed into a given point in the field. So, a positive charge which is placed here will experience a force in this direction, for example. Negative charges will always experience a force opposite to the direction in which the field lines are pointing. Moving on, the spacing of these field lines tells us about the strength of the electric field. The more closely spaced the field lines, the stronger the field, and the larger the force that will be exerted on a given charge. What this means is that an electron which is located here in the field will experience a smaller force than one which is here. The final thing we should talk about for now is how electric fields help explain how the Van de Graaff generator from our previous video produces sparks. When the dome of the Van de Graaff is positively charged, the electric field lines will be pointed away from it. What this means is that the negative electrons in the discharge sphere will experience a force opposite to the field direction and towards the Van de Graaff dome. If the charges build up to a certain level, there will be a spark between the dome and discharge sphere. Sadly, that's about it for our final electricity video. Hopefully, you could tell that this is one of the topics that I really love, and maybe you even feel the same way now too, or at least that you're feeling pretty confident for any electricity questions that might come up in your exams. Good luck and call back soon.